Good day, everyone. We're now going to talk about normal distribution. Normal distribution is a fundamental concept in statistics representing the distribution of a variable in a symmetrical bell-shaped curve. To understand normal distribution, let's break down its key components. Mean, this is the arithmetic average of all the data points, and in a normal distribution, the mean, median, and mode are all equal and situated at the center of the curve. Median. The median is the value that lies in the middle when all the data points are arranged from least to greatest. Mode. This is the value that appears most frequently in the data set. While a normal distribution is symmetric, data can sometimes exhibit skewness. Skewness or skewed is when the majority of the data values fall to the left or right of the mean. And it is classified into two. We have the negatively or left skewed distribution and positively or right skewed distribution. So as you can see here on our section B scores, the majority of the data values fall to the right of the mean, creating a longer tail on the left side of the curve. While on our section C scores, most data values cluster left to the right of the mean, resulting in a longer tail on the right side of the curve. And now, let's explore the properties of a normal distribution. Remember that normal distribution curve is bell-shaped. Second, the mean, median, and mode are equal and located at the center of the distribution. Third, it is unimodal, or it has only one peak or mode. It is also symmetrical, meaning that its shape is identical on both sides of a vertical line passing through the center. It is continuous, meaning that there are no gaps or holes in the curve. The total area under the curve is equal to 1 or 100%. Lastly, within one standard deviation of the mean, about 68% of the data lies. Within two standard deviations, it's around 95%, and within the three standard deviations, it's approximately 99.7%. This table lists different statistical measures and uses Greek symbols to represent the population parameter and lowercase Latin letters to represent the sample statistics. And remember that this is very important for you to memorize to avoid confusion. So we have here the size, the mean, variance, standard deviation, proportion, correlation coefficient, and regression coefficient, and its different symbols and population parameter and sample statistic. Let's consider an example. A population of 10,000 IQ scores. If these scores are normally distributed with a mean of 100 and a standard deviation of 16, we can visualize the distribution using a normal curve. So we have here a given population of 10,000, mean of 100, and a standard deviation of 16. So the first thing that we can do here is to understand the normal distribution curve. The number 34.13% represents the percentage of data falling within one standard deviation from the mean in a normal distribution. This percentage is derived from the empirical rule, which states that approximately 68% of the data falls within one standard deviation from the mean. So 34.13% represents the portion of the distribution that falls between the mean and 116. 34.13% represents the portion of the distribution that falls between the mean and 116. That's why we multiplied it to our population size, which is 10,000, and come up with 3,413. In the second one, the number 13.59% represents the percentage of data falling between 1 and 2 standard deviations from the mean in a normal distribution. Since this range extends symmetrically around the mean, it represents the portion of the distribution between 1 and 2 standard deviations above them. Hence, the calculation for the number of scores between 116 and 132 is 13.59% of 10,000, which equals 1,359 scores. In the world of statistics and probability, understanding how we collect data is crucial. Let's dive into the realm of sampling methods. But first, here are some terminologies that we have to remember. When we describe the entire population, we use parameters. But when we're working with a sample, we use the word statistics with S. Parameters describe a population. Statistic without S describes a sample. Census or complete enumeration, it is the process of gathering information from every unit of the problem. Non-probability sampling is the sampling procedure. Probability sampling gives every element of the population non-zero chance of being selected. We have different methods of sampling. We have simple random sampling, stratified random sampling, systematic random sampling, and cluster random sampling. Simple random sampling. To put it simply, simple random sampling gives equal chances of being drawn or selected to each member of the subset. Some of its examples are selecting lottery numbers, choosing a survey, and picking a book from a library. Simple random sampling, it is classified into subpopulations called strata. Every element in a stratum has the same chance of being chosen. We have two types of stratified. We have equal allocation and proportional allocation. And some of its examples are testing a new medicine and studying student performance. Systematic random sampling, method in which the elements to be included from a population are being selected at regular interval. Some of its examples are selecting customers for a satisfaction survey and testing soil samples from a field. If stratified is classified into subpopulations called strata, cluster sampling is divided into clusters. And cluster sampling consists of elements from the selected clusters only. Its examples are surveying households in a city and studying animal populations. And now, let's talk about non-probability sampling, where not every member of the population has an equal chance of being selected. First, purposive sampling. Purposive sampling involves selecting participants based on specific characteristics or criteria. Second, quota sampling. It involves selecting participants to fill quotas based on certain characteristics such as age, gender, and ethnicity. Its example is a market researcher conducting a survey might set quotas to ensure they interview equal numbers of men and women from different age groups. Accidental haphazard or convenient sampling. Accidental sampling, also known as haphazard or convenient sampling, involves selecting participants who are readily available or easy to reach. It's when a student conducting a survey on campus might approach classmates during lunchtime or their breaks. Expert or judgment sampling. It involves selecting participants based on the researcher's expertise or judgment. Fifth, the modal instance sampling. It involves selecting participants who represent the most typical or common case within the population. Sixth, the diversity or heterogeneity sampling. It involves intentionally selecting participants to represent various characteristics or traits within the population. Remember the word represent. And lastly, we have the snowball sampling. It involves selecting initial participants who then refer other participants. Example, a researcher studying rare diseases might start by interviewing patients who are already part of support groups, who then refer other patients they know.